Okay, start recording. So today we're going to do chapter 5 and chapter 8. Okay, so usually I'll teach these two chapters together, which is integration and differential equations. So these two topics are actually related. Okay, and it's actually a continuous. Okay, so for this topic, okay, I'm going to split into 8 sections. Okay, we have a basic rule, basic integration, some rules about trigo, advanced formula, okay, special formula with proof, integration technique, okay, application and extra. For your information, your exam, okay, will be focused on this, okay, which is integration technique. Okay, integration technique. So from these 8 sections here, A, B, C, D, E, F, G, H, okay, the learning of this topic will be when you enter B, you will be expected to know A. When you enter C, you will be expected to know AB. When you enter D, you will be expected to know ABC. Of course, since the topic is the exam style, we're going to focus on section F, that means you will be expected to know A, B, C, D, E. Okay, so when you practice your topic, your exercises, okay, you practice it section by section. Okay, let's start, okay, with the section A, basic rule. Okay, let's try to recap about the rule. Basic rule says if, okay, number one, if d dx of capital F equals to small letter f, then integrate of small letter f equals to capital F plus c. This is what we call indefinite integration. Okay, net integration. Okay, the answer is always an expression. Okay. Number two, if d dx of fx equals to small letter f, then integrate of ab equals to capital FB minus capital FA. This is what we call definite integration. Okay, the answer that you got is a number. Okay. Number three says if you have plus minus of two expression, you can do the integration separately. Number four says if you have a multiple in front of your fx, so you can actually take out your multiple before you do your integration. Number five says if you have a constant will go to kx plus c. Number six says if you have a AB, okay, with AB, we can actually change the limits to negative of BA, okay, will be a negative relationship. Number seven say if you have an improper integration from P1, you'll be expected to remember, okay, your P1 improper integration towards the infinity or towards the asymptotes, okay. That will be the basic rule. We know, as you can see, these are actually the same rule from your P1. Okay, we're not going to discuss about details about this. You'll be expected to know about the rule already. Then comes to section B, basic integration. Okay. In your syllabus, there will be some expression that you are expected to know about the rule. Okay, so why do we call this section as a basic integration? Yeah, because this is a direct reverse of differentiation. Okay, that means if you do know about the differentiation rule, okay, you should know about the integration rule. Okay, number 8 says integrate of xn, it give you x power of n plus 1 over n plus 1, provided your n is not equals to negative 1. Number 9 says if you have an integrate of ex, go back to ex. As you can see, this is what I meant by it's a direct reverse of the differentiation, because we know that ddx of ex goes to ex. Okay. Number 10, okay, integrate of 1 over x give you ln x, okay, with a modulus. Okay, again, this is another demonstration of the direct reverse of the differentiation, because in differentiation, you know that for differentiation of ln x give us 1 over x. You already learned about the proof. So this is just a reverse relationship. Okay, number 11, integrate of sine goes to negative cos. Number 12, the integrate cos go to sine. Number 13, integrate of secant square go to tangent. Number 14, integrate of secant tangent go to secant. Number 15, integrate of cosecant cotangent go to negative cosecant. Number 16, integrate of cosecant square goes to negative cotangent. Number 17, integrate of 1 over 1 plus x squared gives us arctangent of x. Okay, as you can see, all of everything here, they are directly reverse of your differentiation. But there is something that you do need to aware. You can see that 11 and 12, I have integration of sine and cos, but I don't have integration of tangent. I don't have integration of cotangent. I don't have integration of secant. I don't have integration of cosecant. Okay, they are not fall under here. Okay, they are fall under special formula. Okay, they are fall under special formula. This will be something extra that you might need to know later. Okay, from the rule here, you have rule 18. Okay, so for section B, for rule 8 to rule 17, if x is a linear form ax plus b. Okay, so this linear form is important. You can change the formula by changing the x into ax plus b and multiply by 1 over a, right hand side by 1 over a. For example, if you look at 13, okay, if you look at 13, so you have an integrate of secant square ax plus b dx. Okay, so 13 like this. So, but you can actually copy the formula, okay, which is tangent of ax plus b. In front, you just replace, multiply by 1 over a. Okay, this is how this it works. Okay, some students will say, what if it's not a linear form? Okay, if it's not a linear form, rule 18 cannot apply. If it's not a linear form, rule 18 cannot apply. Okay, so over here, again, just like differentiation, you have bunch of exercises that you can do. So this section will be important, okay, so that you actually familiarize yourself with the formula. If let's say you are you need to memorize the formula, or actually need to copy down the formula, you can actually screenshot the screen, okay, and save it in your file. Okay, so the exercises, okay, I will leave it to you. Okay, next, there will be some rules about trigo. So since this one we deal with trigo, therefore we expected students to know about trigo formula, which is chapter 3. Okay, so please understand that when the teachers enter these sections, we already have some sort of expectation. What kind of expectation? We expected students to know trigo. Okay, there will be 2 rules about integration that we can actually apply here. Rule 19 says, okay, for trigo with power more than 1, we can change it into power 1 using trigo formula before integration. Let's say I have an integration of sine power 3. Okay, I can use the triple angle formula, which is sine 3x equals to 3 sine x minus 4 sine qx. Oh, for maybe some of you already forgotten what exactly is triple angle formula. Okay, please go back to your trigo topic. Okay, then you can see that by rearranging this, I have a 3 sine x minus sine 3x over 4. Okay, you can see from this rule 19, we chop power more than 1, which is 3. Okay, then change it into power 1, which is the power 1 here, power 1 here. Okay, so of course I simplify them, okay, rearrange them nicely. I have a 3 over 4 integrate of sine x minus 1 over 4 of sine 3x. Okay, so integrate of sine x gives us negative cos. Okay, integrate of the sine 3x give me negative cos over 3. Therefore, this will be the answer that I get. Okay, rule 20. Rule 20 says, for multiplication of 2 trigo, change it into plus minus of 2 trigo using trigo formula before integration. Okay, so over here, the example that I have is, if let's say I have integration of 2 sine 3x cos x. Okay, please understand this is 3x, this is x. Okay, some students, when they see sine 3x, okay, and they memorize the formula, they immediately replace it with the triple angle formula. But from earlier, we see that the triple angle formula actually increase the power. We don't like that. We don't want to increase the power. Okay, therefore, increase the power may not be helpful. Okay, increase the power may not be helpful. So over here, we actually use the factor formula. Okay, sine A plus B plus sine A minus B equals to 2 sine A cos B. So in this case, we're matching with the question. My A is my 3x, my B is my x. Therefore, become 3x plus A, 3x minus A. So you can see sine of bracket 3x plus A, plus B, 3x plus x plus sine of 3x minus x. So I have total of 4x, I have total of 2x, okay, here. So, and furthermore, they are power 1. Then, okay, integrate them. So I have a negative 1 over 4 of cos 4x and negative 1 over 2 of cos 2x plus c. Okay, this will be section C. After that, okay, again, there will be exercises that you actually can do. Okay, if let's say you're having a problem for this section, you need to ask. Okay, you really need to ask your friend, ask me, ask whoever that actually can do. Okay, one thing for sure is you need to familiar with the trigo formulas. Next, we go to advanced formula. Okay, this advanced formula, you can see that I have a fx here, fx, fx, fx here. Okay, this fx can be in any form. Okay, xx in any form. Okay, so it can be a polynomial, it can be a trigo, it can be exponential, it can be a log, it can be arctangent. Okay, inverse trigo. So this fx here can be any form. So therefore, this is a general rule. Okay, so what do we apply for this rule? If you see integration of f prime x, fx r, okay, then you can actually write as a fx r plus 1 over r plus 1, where r is not equals to negative 1. So some students will ask what happened to the f prime? It's gone. Okay, it just vanished. Okay, no longer appear. Number 22, if you have a f prime x e f x, then I will have e f x. Number 23, if you have a f prime x over fx, a fraction form, then you have a ln of modulus fx. Okay, so the best way to actually teach you is by using example. Okay, so let's see what kind of question that we have. Let's say I have a cos x of sine x squared. Okay, cos x sine x squared. So you can see this is trigo, but we do not apply the trigo formula here. It happened to be in matching with this formula. Therefore, I can actually write the answer as sine x power 3 over 3 plus c. Okay, similarly, if I have a cos x e of power sine x dx, you will see that it's matching with the formula. Okay, then I will have e power of sine x plus c. Okay, okay, for example, for 23, if let's say I have a cos x over sine x, okay, that means it may be earlier cos x over sine x is cotangent, isn't it? So cotangent come from here. Okay, cotangent can be written as cos over sine. You will see that the top is actually the differentiate of the bottom. Therefore, I will have ln of modulus sine x plus c. So again, some students will say that must I write the modulus? Yes, you must write the modulus. Okay, and for 24, okay, it can be the question can be appear as rule 23, okay, with partial fraction. So that means you will be expected to apply your partial fraction correctly. Okay. Then over here, okay, I will have exercises. Okay, I split the exercises according to the rule. So this one will be using rule 21. Okay, this one will be using rule 22. Okay, this one will be using rule 23. And this one will be using rule 24. Okay, so for your information, I didn't give an answer over here. Okay, because I need you to learn how to check answer by yourself. How to check answer. How to do checking. Okay, so if it's involved with trigo, okay, if it involved with trigo, make sure you key into a radian mode. Okay, so this is something that you need to remember. After that, you use the integration button. Okay, this is whatever the question that you actually key in. Okay, then you actually insert with the interval 0.1 and 0.2. Okay, then you can actually compare with the substitution 0.1 minus 0.2. Okay, f of 0.2 minus 0.1, okay, to see whether you have the same answer or not. If you have the same answer, you know that you got it right. Okay, you know that you got it right. So this checking thing, okay, is to help to boost your confidence whether you actually do the question correctly or not. Okay, you need to try to do this. Okay, so therefore this section I didn't give any answer. Then E, special formula with proof. Okay, these formulas, okay, appear from the compilation of passes. Okay, so 25 we have a sine of square, sine square. Okay, 26 a cos square. Okay, so some students will say that, hey, isn't this as same as the trigo rule above, which is change the power more than 1 into power 1? Yes, it's similar. Okay, but it's just that right now I'm showing you other approach. Okay, then after that we also have 27. Okay, integrate of ln. 28, integrate of arctangent. Then 29, okay, integrate of tangent, integrate of cotangent, integrate of secant, integrate of cosecant. Okay, that I have showed you earlier just now, a cotangent. Okay, how we actually use the advanced formula to actually get the answer. Okay, so since this part we need the proof, okay, we're going to write out the working one by one. Okay, let's say for 29. Okay, 29. Okay, I think I better use another color. Okay, 29. So integrate of tangent x. Okay, tangent can be written as sine x over cos x. You see there is a fraction. So from this fraction here, okay, so we want to match the top as a differentiate of the bottom. So the bottom is cos x, differentiate of cos supposed to get negative sign. I don't have a negative sign, so I make it a negative sign. Now the top is the differentiate of the bottom, okay, which I allow me to use the rule 23. Okay, I will have negative of ln modulus of cos x plus c. And this is a negative. Negative can actually bring up as a power. Okay, so I will have a cos x power by minus 1, okay, plus c. That actually gives me ln of secant x plus c. Okay, so this is number 29. Number 30. Okay, although that I have already written it just now, okay, just for the sake of writing, I write it down again. Okay, cos x, okay, cotangent x, sorry, cotangent x, integrate of cos x over sine x. You can see that the top, it is the differentiate of the bottom. So by rule 23, okay, I have ln of sine x plus c. Okay, 31. Okay, 31. I have integrate of secant x equals to ln secant x plus tangent x plus c. For these two, it's difficult to actually understand how to actually do the rule. These two we actually remember by using differentiation. We use differentiation to help us remember the proof. Okay, so for 31, okay, so let's say I ddx of ln modulus of secant x plus tangent x. Okay, so this is ln. Differentiation says, okay, differentiate of the inside you put on above the fraction, then whatever that you have inside you write it below. Okay, let's see what do we get. Okay, differentiate of secant give us secant x tangent x. Then differentiate of the tangent give us secant square x. Okay, what happened next is this on top I have secant and secant, same thing that I can actually factor it out. Therefore I have a tangent x plus secant x. Then the bottom I also have a secant x plus tangent x. You will see that, hey, the top and bottom you have exactly the same thing. Therefore they can be cancelled off. Hence what I get is a secant x. Done. So since integration is a reverse process, so integrate of the secant will give us ln of modulus secant x plus tangent x. Same goes for 32. Okay, I try to differentiate ln of cosecant x plus cotangent x. Okay, let me try to draw some space. Yeah. Okay. Okay, over here equal. So this is ln. So I draw a fraction. Okay, whatever inside I write at the bottom. Then differentiate of the inside I write on top. Differentiate of the cosecant give us negative cosecant x cotangent x. Okay, if you haven't memorized the differentiation formula, please go back to memorize the differentiation formula. For cotangent x, after differentiated, you give us negative of cosecant square. Okay, similarly, I see that I have a cosecant x that I can actually factor out. I factor out negative cosecant x. Then I left with cotangent x plus cosecant x over cosecant x plus cotangent x. You will see that the top and bottom is actually the same thing, which I can actually cancel it out. Okay, therefore I left with negative of cosecant x. So since we know that integration is a reverse process of the differentiation, okay, so integrate of cosecant x give us negative ln of cosecant x cotangent x. This is how it works. Okay. Over here, you will see that under this special formula, okay, I have done 29, 30, 31, 32. Okay. What about 25, 26, 27, 28? Okay, we haven't learned about the method yet. Okay, we will come back to this later. Okay, we will come back to this later. Next, okay, section F, integration technique. Okay, so this is the part that you need to practice a lot. Okay, as I say, P3 will be focused on integration technique. And furthermore, according to the design of the questions, we already expect students to know A, B, C, D, E. Okay, section A, B, C, D, E. So, okay, the first technique that you are supposed to know is called by substitution. Okay, by substitution. So, sometimes according to the design of the questions, okay, they will give you what to substitute. Okay, they will give you something to substitute. Further math students, they need to figure out the substitution by themselves. Okay, so how do we actually do this substitution question thing? Okay, let's see. So I have my questions as integrate of x square root 2x plus 5 dx. Then if I have my integration, sorry, I might have my substitution, u equals to 2x plus 5. So the very first thing that you need to do is do implicit differentiation, also from the differentiation topic last lesson. Okay, then from here you have a du over dx equals to 2. Okay, so you will see that dx equals to 1 over 2 du. Okay, dx. For your information, this is not a proper mathematical writing. Okay, this is just to simplify so that you actually know what to do. That's all. Okay, so over here, this x I'm going to substitute into u minus 5 over 2. And this square root of 2x plus 5, I'm going to write as a square root of u. And this dx, I'm going to replace it by 1 over 2 du. Okay, so you can see that all the x component that you have inside from the questions all change into u. Okay, after that, we simplify the form. Okay, so what do I get? So 1 over 2, 1 over 2, 1 over 4, u power 1 power half, so 3 over 2, then minus of 5 over 4, then u power of 1 over 2 plus c. Sorry, du. Okay, now I change it into something nicer. Okay, I'm going to continue from here. So integrate of 1 over 4 u 3 over 2, okay, minus 5 over 4 u 1 over 2 du. Okay, now I do my integration. Okay, 1 over 4 u power of 5 over 2 over 5 over 2 minus 5 over 4 u power of 3 over 2 over 3 over 2 plus c. Okay, then we simplify. I have a 1 over 10 u power of 5 over 2. Okay, and I will have a 5 over 6 of u power 3 over 2 plus c. Don't forget that your original question is in the form of x. U is just to help us do the integration. So don't forget to actually change your u back to x. So I have a 1 over 10 of 2x plus 5 powered by 5 over 2, okay, minus by 5 over 6 of 2x plus 5 powered by 3 over 2 plus c. This will be your answer by using substitution. Okay. What if you have the trigo form? So similarly, you can see that I have my something to substitute. Okay, and I have my questions here. So how do I actually do my substitution? Okay, from the one information given, I have u equals to sine x plus 1. Okay, therefore I have an implicit differentiation du dx equals to cos x. Okay, by writing cos x as my subject, I 1 over cos x and du. Okay, again, as I say, this is not a proper maths writing. This is write it out to actually help you to understand what you're actually doing, that's all. So over here, from the questions, okay, from the questions, I have an integration of cos x sine x 1 plus sine x power of 3 dx. Okay, everything in the form of x, I need to change them. So cos x, nothing to change. I'll leave it there first. Okay, sorry, I'm missing an x term here. X. Then the sine x, I change to u minus 1. Okay, 1 plus x, I change to u power 3, and the dx, I change into 1 over cos x du. So you can see that the cos x and the cos x here got cancelled off. Okay, so of course, next one, I will simplify the form. So I will have u power of 4 minus u power of 3 du. Okay, I do my integration, 1 over 5 u power 5 minus 1 over 4 u power 4 plus c. Okay, don't forget, this is not your original questions. Okay, your original question is in the form of x, so remember to change it back. So I have 1 over 5 of, okay, sine x plus 1 power 5 minus 1 over 4 sine x plus 1 power 4 plus c. That will be your answer. Okay, next. Okay, so what if I have a 6x and x squared? So they purposely didn't give you the substitution. Okay, so during exam, if they didn't give you the substitution, of course you are expected to actually figure it out by yourself. So some students will say that, okay, how do I even know what is the correct substitution? Okay, these students who actually say this, that means they actually didn't practice the exercises. So the only way that for you to actually know what to substitute during exam is actually from your past experience, depending on how much exercises that you do. Okay, if you didn't do any questions, of course you wouldn't know. But for students who actually did put the effort and actually try out all the questions, they were able to tell, oh, the substitution is u equals to x squared. Okay, then du dx equals to 2x. Okay, then I write as a dx in the form of 1 over 2x du. Okay, then from the questions, I have integrate of 6x ex squared dx. So the 6x I do not disturb, and x squared, so I change to u, then the x I change into 1 over 2x du. So you will see that I got this cancel off, left with a 3. Okay, therefore I have a 3 eu du. Now we managed to simplify the integration into something nicer that actually give me 3 eu plus c. Okay, don't forget to change the u back into x, so I have 3 squared plus c. Okay, next, what happen if they give us a limit? Okay, a limit, so 2 and 0 here. Okay, this one same thing, they didn't give us the substitution, so we need to figure out by ourselves. So I will let u equals to x plus 1, so du dx equals to 1, so dx equals to du. Okay, then you see there's a limit here. So the limit, you have an x value and the u value. Okay, x value here, we need to change it into a u value. So when x equals to 2, u equals to, according to your substitution that you have, equals to 3. When x equals to 0, u equals to 1. Okay, so according to your substitution. After that, you do your integration. So the question is 0 to 2 x of x plus 1 power 3 dx. Okay, then we have now substitute with the replaced by the u value. Okay, so u equals to 1, u equals to 3, x change into u minus 1, then this one change it to u cube, dx change into du. Okay, now you see that everything is in the form of u, so simplify it. 1 3 u power 4 minus u power 3 du. Okay, so you do your integration, u power 5 over 5 minus u power 4 over 4. Okay, with a 3 and 1 here. Okay, substitute the 3, substitute 1. So 3 power 5, 2, 4, 3 over 5 minus 3 power 4, 81 over 4. Okay, minus by 1 over 5 minus 1 over 4. Okay, simplify the number. So 243 over 5 minus 81 over 4 minus 1 over 5 plus 1 over 4. So you have a 28.4. Okay, as your answer. Okay, similarly, if you have a limit with the one with trigo, okay, so we do it as exactly the same way. Okay, so now let's say I have a let u equals to 1 plus sine x. Okay, therefore I have a du dx equals to cos x. So I will have a dx equals to 1 over cos x du. Okay, then when x equals to pi over 2, so I substitute pi over 2 inside, my u value equals to 2. When x equals to 0, my u value substitute inside equals to 1. Now I do my integration. Okay, this original question is 0 to pi over 2 cos x of 1 plus sine x power 1 over 2 dx. Okay, then we change the form. Okay, pi over 2 change to u equals to 2, 0, x equals to 0 change to u equals to 1, cos x, nothing change. This is a u power of half, dx change into 1 over cos x du. Okay, you will see that the cos x here cancel off. So you integrate of 1, 2 of square root u du. Okay, integrate it. So I have a u power of 3 over 2 over 2 over 3. Okay, then 2, 1. Substitute the number inside. So 2 over 3 with 2 power of 3 over 2 minus 1. Okay, so you have a 2 over 3 of 2 square root 2 minus 1 as your result. Okay, then from here you have the substitution questions that you can do. Okay, so please take our time to actually do the question first. Okay, so okay, stop recording. Okay, start recording. The second integration technique that you need to know is called integration by parts. Okay, this one will be important. Okay, so by parts here actually tell you that okay, you have two parts in your integration that they being multiplied together. Okay, we need to split the two parts into this particular form. Okay, then these two parts here that being to multiply together, it can be a polynomial, it can be a trigo, it can be an exponential, and so on and so forth. Okay, therefore, it's important for you to actually recognize what formula to use when what order that you choose as a u of the v prime when you're dealing with the questions. Okay, so the order to choose u, we follow this order: inverse trigo first, ln second, polynomial, trigo, exponential last. Okay, the type of questions we're going to split into a few types of questions. Okay, over here I have a 1 layer by parts. Over here I have a 2 layers by parts. Okay, and over here I have a loop example. Okay, so we will look at them one by one. Okay, so this is the formula. Okay, you can see that I have x and cos x being multiplied together. Okay, x is a polynomial, cos x is a trigo. If you follow the order, okay, which one goes to u, you will see that polynomial goes to u because trigo is later. So u equals to x, v prime equals to cos x. Then what happened to my u? The u, I do differentiation. 1. What happened to my v prime? V prime will be integrated, become the integrate cos becomes sine. Okay, from here you will use this as a pairing. Okay, this is 1 time by parts. Okay, 1 layer by parts. So from the questions, I have integrate of x cos x dx. Okay, so u and v first. So x sine x, then minus integrate u prime v. So 1 times sine x. So sine x dx. Okay, then x sine x, already done this part. So integrate of the sine x goes to negative cos x, then plus c. So you have x sine x plus cos x plus c as your result. This is a 1 layer by parts. Okay, let's go for another example. Okay, so let's go for 2 layers by parts. Okay, so yeah, okay, I have integration of x squared ex. Okay, x squared ex. So x squared is one item. Okay, ex is another. They're being multiplied together. Okay, so which one will be your u? Which one as your v prime? So go back to this order. You will see that polynomial is in front, exponential is at the back. So we will choose u as x squared. Okay, then v prime as ex. So u prime goes to 2x differentiated, v goes to integrated ex, so these two will be pairing together. Okay, let's see what do we get first. Okay, from the questions, I have a x squared ex dx. Okay, these and these will be paired together, or be x squared ex. So minus these two will be paired together, integrate of 2x ex dx. Okay, you will see there is another round of by parts. Okay, because these two things being multiplied together. So I will have a 2x as my u, okay, and v prime as my ex. Similarly, so u prime equals to 2, v equals to ex. Okay, then from here, x squared ex, this one is already done, minus. Okay, when you do this part, please make sure you do a bracket, okay, so that you do not confuse with a plus minus sign. Okay, so over here I have a 2x ex, 2x ex minus, okay, 2ex dx. Okay, so a lot of students they can do the by parts, but ended up with they give a wrong answer because of a messing up with the plus minus sign, being careless lah. Okay, so hopefully you don't do that kind of mistake. So I have a x squared ex, then minus of 2x ex, then plus by 2ex dx, then in the end x squared ex minus 2x ex. Okay, then over here I will have a 2ex, yes, 2ex plus c. That will be your result. You can see that we did the by parts for 2 times. This is a 2 layers by parts. Okay, this is a 2 layers by parts. Next, you have the loop example. Okay, so this one is actually from the special formula rule 25. Okay, rule 25. So I'm using this question as an example for the loop example. What does that mean by it's a loop example? Okay, you cannot keep continuing doing by parts multiple times because you realize that it's just going forever. Okay, it's just going forever. It won't stop. Okay, it's a loop example because at a certain point it will actually close the loop and actually give you the answer. Let me demonstrate to you. Okay, so over here the question is sine square x dx. Okay, I write it in the form of sine x and sine x. Okay, then I will have my u equals to sine x. Okay, my v prime equals to cos x. So I have my u prime equal, sorry, this is u v prime as sine x, my mistake. Okay, u prime will differentiated goes to cos x, and v, okay, will be integrated from the sine x give a negative cos x. So these two will be paired together. Okay, then these two pair together, I have negative of sine x cos x, then plus by, okay, cos x become square. Okay, the negative I already joined with the one in front. Okay, okay, you will see that this is a cos square. Okay, cos square here. So you will notice that if I do by parts here, cos square eventually give me sine square. Then sine square, then give me cos square again. It will just keep going forever. Therefore, what will be the correct approach to actually do this question? Okay, we will change this cos square into 1 minus sine square x. Separate them. Integrate 1 dx minus integrate of sine square x dx. You will see that the left side and the right side have a same item. Okay, then that means you can actually move it to the other side. So become 2 of sine square x dx. Over here, this one become 1. Sorry, this one integrate of 1 become x. So I write it in front. X minus sine x cos x. I have 2 times. My question is only 1. So I divided by 2. So 1 over 2, okay, x minus sine x cos x. I finish my integration, I put a plus c at the end, done. This will be the loop example. Okay, so as therefore from here you will see that the rule 25 from the special formula, okay, is actually using by parts. Let's go back to the special formula. Okay, so over here you will see that 25, okay, this is your sine square. 26 is using the similar way, okay, cos square. What interesting is 27 and 28. I'm going to show you 27, 28, the proving for those two. Okay, now let's see. Okay, let's look at 27. Okay, 27. So integrate of ln x, okay, is actually by parts. We will use u equals to ln x, v prime equals to 1. Then u prime equals to 1 over x, v equals to x. These two will be multiplied together. So I will have a x ln x minus these two together. So 1 over x times x become 1. So I have a x ln x minus x plus c. Done. So what important is this is a multiply by 1. Next, 28. So integrate of arctangent x dx. Okay, I'm going to use u equals to arctangent x. Okay, v prime equals to 1. Then u prime equals to 1 over 1 plus x squared. This is differentiation. Again, if you haven't memorized the differentiation rule, please go back and revisit the differentiation topic again. So, and the v prime goes to x. These two will be combined together. Okay, x and the arctangent. So x arctangent x minus this one, integrate of x over 1 plus x squared. Okay, the x arctangent x is done. But what about this? What exactly is this? First clue that you have is this is a fraction. Therefore, it may be using rule 23. Okay, rule 23 says the top must be the differentiate of the bottom. Okay, if I have a bottom 1 plus x squared, differentiate of the bottom, I should get 2x. I should get 2x. So I don't have a 2x there. So I create 2x. Now the top is actually the differentiate of the bottom. I can apply rule 23 now. Ln of 1 plus x squared plus c. Done. So this is how we actually get this thing. Okay. So over here, back to the top. Okay, so 27, 28 is done. Okay, 23 done by substitution. 34 done by parts. Okay, you already seen the example of 1 layer by parts, 2 layer by parts, loop example, and now comes to the exercises. Okay, please take a moment to actually do the exercise before you actually continue with the next part. And the last technique is called separating variable. Okay, separate. This is your differential equation. Differential equation. Okay, so this differential equation, okay, is in the form of dy dx equals to something x times something y. Then we actually can separate them into y together, x together. So y together, x together. Okay, so for your syllabus, if these kind of questions appear, it definitely separatable. Okay, definitely separatable. If let's say you cannot separate them in your P3 question, that means you're still weak in algebra. Okay, for P3 wise, it's definitely separatable. So let's look at this. So I have a 1 plus x squared dy dx equals to x arc tangent y. Okay, this is a tangent y, not arctangent. So I need to get them y together, x together. So I write it in the form of 1 over tangent y dy equals to x over 1 plus x squared dx. Put integration sign, put integration sign. So this one give me cotangent y. This one give me 1 over 2x of 1 plus x squared dx. So cotangent y from the special formulas. So I will have a ln of sine y. Okay, this one will give me 1 over 2 ln of 1 plus x squared. We just did this just now. Okay, so over here I have a 2 integration done. Okay, usually we will put the plus c after in the integration, isn't it? Okay, because this is a differential equation, you only need to do plus c at the single side, either the left side or the right side. Okay, so this one of course it look ugly at the moment. Whether the question want you to rearrange or not will be up to the question. Maybe the question asks you to rearrange into something nicer. Okay, so this will be up to the question. Okay, next example. Let's see. So I have a dy dx negative 3y minus 2, 2x plus 1, x plus 2. Okay, so I have a 1 over y minus 2 dy. So equals to negative 3 over 2x plus 1. Okay, x plus 2 dx. So integration. Okay, so over here, okay, this on the left side, integrate of 1 over y minus 2 is ln of y minus 2. Okay, on the right side, I need to do partial fraction. This is a non-repeating linear factor, therefore I'm going to do shortcuts. So 2x plus 1, so x plus 2 dx. So I will have cover this negative 3 over blank plus 2. Then over here, I have negative 3 over 2 blank plus 1. So I'm going to fill in the number with negative 1 over 2. This one I'm going to fill in with negative 2. Okay, what answer do I get? So integrate of negative 3 over 2 minus 0.5. So I have a negative 2 up there. 2x plus 1. Okay, then negative 3 over negative 3 plus 1 negative 3. So it's a 1. So 1 over x plus 2 dx. Okay, so finish my integration. So I have a negative of ln of 2x plus 1. Okay, plus ln of x plus 2 plus c. So over here up to this line, I have ln of y minus 2 equals to, okay, negative ln of 2x plus 1, okay, plus ln of x plus 2 plus c. These two, there is a minus in between, okay, I can actually combine them together. So it becomes ln of x plus 2 over 2x plus 1 plus c by using log rules. Okay, the question gives us additional information x equals to 1, y equals to 4. That means it meant for us to actually find the value of c. So ln of 4 minus 2 equals to ln of 1 plus 2 over 2 plus 1 plus c. So if ln 2, so this is 1, you put inside a calculator, this is 0. So c equals to ln 2. Therefore, I have ln of y minus 2 equals to ln of x plus 2 over 2x plus 1 plus ln 2. The question wants us to rearrange it into the y form. Okay, so I have a ln of 2x plus 4 over 2x plus 1. So I have y minus 2 equals to 2x plus 4 over 2x plus 1. Okay, I have my y equals to 2x plus 4 over 2x plus 1 plus 2 as a result. Okay, so this will be the separating variable section. Okay, you will, from the way I do the questions, you need to notice, you should notice that the question no longer tell you what formula to use. Okay, they expect you to apply whatever the integration technique, the formula that you have done earlier. Okay, so please remember, you don't need to complete the entire video, okay, all together. You can practice it section by section. Okay, you should practice it section by section. Okay, then over here, for this technique, integration technique, separating variable, you'll be expected to know all the previous tools already. And over here, there will be questions that you actually can do. Okay, questions given. Okay, I hope that you actually try it. Then comes to application. Okay, rule 36 is not inside P3, so we ignore it. Then this section is application, therefore they can actually ask you anything. So they can ask you area by x, area by y, volume by x, volume by y. They are just the formulas that you need to know how to apply. Okay, for whatever the equation given, okay, let's say like this, maybe there is some sort of by parts involved, that you may need to know how to do it by yourself. And extra will be some extra formulas. Okay, so integration of ax 1 over ln x ax. So where is this formula came from? Okay, again, it's actually came from your differentiation. Same goes for this 42. Okay, log a, so we actually do changing base into ln, then we actually have the special formula here. This is the same as the special formula. Okay, so this is everything of chapter 5 and 8. Okay, integration and differential equation. You can see that a lot of questions given here. Okay, it's totally up to you how much time that you have to spend to actually complete the questions. Okay, so okay, this is everything. Thank you very much. Stop recording.